Hello everyone, good morning. So today we are going to start our new chapter, that is chapter 3, decimals. Before starting off, let's just quickly understand what are the objectives of today's video, that is what are the things that I'm going to cover in this particular video. So without wasting any time, let's start. So these are the objectives that we have to cover in this particular video. First of all, what is it? That is decimal, its introduction and some brief history about it I'm going to discuss with all of you. Then what is the concept behind tenths, hundredths and thousandths? We have to understand all such things, right? And then we will shift into the exercise, that is exercise 3a. Few questions that I'm going to solve, and after last but not the least, that is the summary part. So let's just understand one by one. So first of all, let's just understand about decimals, the introduction part. Decimal word, it is derived from a Latin word. It is derived from a Latin word which is decimus. Decimus, which means base 10. So or sometimes decimal system is called as, or it is called as base 10 system also. So what does base 10 means, and how this decimal word come into existence, which will actually connect that history part also. So when let's just take one example. If I'm talking about what is the half of 10, what is the half of 10, we can easily say 10 by 2, which is 5. But if I'm talking about what is the half of 1, in ancient period, that is 1 by 2, because fractions has already been invented. But in the case of decimal, it is yet to be invented, right? So in that case, scientists face some problems related that if I'm talking about 10, so the answer will be 5. But if I'm talking about 1, we cannot further divide this number, because the last or the simplest form of 1 by 2 is 1 by 2, right? So how will I get an exact number like this when this concept is coming into the place, right? So when we are talking about rupees or paisa, or you can say currencies, in that case we can this decimal system come into existence. So how this play an important role when we are talking about currencies? Let's say 10 rupees note. If I'm talking about 10 rupees note, what is the half of 10 rupees? That is 5 rupees. Coin or note, you can say. So when we are talking about 1 rupee note or 1 rupee coin, so 1 rupee coin, it is a half. What is the half of 1 rupee coin? That is 50 paisa. So when we just add 250 paisa, what we get? 1 rupee. What we get? 1 rupee. So in that case, scientists, mathematicians feel that when something is lesser than 1 rupee and the same thing is being added to each other, then we can get 1 rupee coin. In like that way, if I'm talking about something, some number, let's say 5 is there, so we cannot plus 5 over here, because the answer will be 10. So the contrary part is that in that case, when scientists were facing problem, they introduced some type of things that is called the base 10 system. What do you mean by base 10 system? Base 10 system means it will divided by 10 only in both the side, in left hand side as well as in right hand side, so that the answer will be 0.5. In that case, the answer will be 1. So the answer will be 1. So this type of system has been come into existence after facing a problem of these issues, that is 50 paisa, or it's a, you can say in foreign countries some cents, pounds will be there, no? So I'm just talking about my our own currency, that is rupee, and if you are talking about like 50 cents or pounds, the same things will be repeated on. So what I'm talking about is this base 10 system is nothing but this one, that is by 10. So after that, why it is called only base 10 system? Because what in fractions we have learned about decimal fraction. What do you mean by decimal fraction? The numbers, let's say 5, the numbers which is there in the denominator will be the multiples of 10 only, which is the multiples of 10 only. If I'm talking about 100, so that is basically 6 by 10 into 10, or you can say 10 into 10 square. if you know about power, I have already discussed this concept with you as well. So 5 by 10, or you can say 6 by 100, or you can say 7 by 1000, all of these are called decimal fractions. Decimal fraction. Why? Because it is coming under the base 10 system. So this is all about the history, and some more histories are also there, but I can't share all of the things because the videos will be it will be long enough. So let's just keep it short. That is the introduction and some brief history about decimal. So after that we will discuss about what is 10th, 100th and 1000 form. So let's just continue with that concept only. So this is the new concept, that is tens, hundreds and thousand. But let's just continue with that positive number, or you can say positive, or you can say natural number, right? If I'm talking about, let's say 7204, so this is the position of what? Ones, right? This is the position of tens. This is 100, or you can say 1000, right? The same system will be going on in the decimal point. So this is the distinction between decimal points, decimal numbers or natural numbers, right? So after point, the decimal numbers will be come into play. So if I'm talking about, let's say 1, 2, 3, so this 1 is nothing but tenths. Why this is tenth? Because if I'm talking about, let's say 1 by 10, so 1 by 10 is nothing but 0.1. So how I find out that 0.1? Just simply divide 1 by 10. So how will I find the answer? First of all, we have to put one point over here. When we put one point over here, then immediately that 0 will come into play, and then 10 into 1 will be what? 10. So the answer is 0.1, or you can say 0.1. Why 0.1? Before point, if nothing is there, you can replace that nothing with 0. If you want to add thousands of 0, that is no problem. If you want to add only 1 0, that's okay for it, right? So if you take 0.1, the both things are absolutely same. So the concept is that when the denominator is 10, 1 by 10, no? So that 1 by 10th is nothing but tenths. So when the denominator will be 1 by 100, it is saying about 0.001, right? 0.01, sorry, 0.01. So 0.01 is 1 by 100, which is the position of hundredths. So in that case, when after point only one number is there, so it is showing about tenths place. So when the after point, the second position will be, in that case the second position hold, which number holds that second position? That is 2. So 2 is nothing but hundredths, and 3 is nothing but thousandths. All right, thousandths. So these things are relevant to that base 10 system. What do you mean by base 10 system? Where the denominator of that number is 10, or you can say the multiples of 10. So that is the concept of tenths, hundredths and thousandths. What is that? Basically, after point, the numbers which are being there, it is represented by some names. What is that name? Tenths, hundredths and thousandths. Or if the numbers will continue for 10,000ths, lakhs, no problem. It will keep going on like that way. The difference between in that system and that system, what is the difference? The difference is only in the ones place, right? So in that natural number system, the number which is in the last holds that position of ones. But in that case, in the point, after point, what is that number? That is 1. The first number will hold the position of tenths, not the ones. All right, I think this concept is much more clear to you. So after clearing out all such things, the basic thing I think you have understood. Now let's just continue exercise 3A. So let's just start exercise 3a. What is the first question? Write the expanded form of the following decimals. So before starting off, let's just understand about one more topic that is left over. That is about like decimals and unlike decimal. It is like the same concept as we have learned in fractions chapter. That is like fraction and unlike fraction. Both are same exactly. So when the point is like 0.123, or you can say 3.143, so in that case both are like fractions, like decimals. How? Because after point the number are absolutely same. The quantity of number, the number is it is not same, but the quantity of number, here the total numbers is 3 and here the total numbers are 3. So in that case both are like decimals. So first of all, one more thing that I think you must have some confusion, that is it mandatory that before the point the number should be like the number of quantity should be same? It is not mandatory, because if I take 34.143 or let's say 729.879, in that case also these two are like decimals, because we are just concerned about after point parts, how many numbers are there. So in that case both the numbers contain, all after decimal how many numbers are there? Only 3 numbers. So in that case also these two are like decimals, right? These two are like decimals. So what is that left behind? If I'm talking about, let's say 34.143 and 1.1, so these two are not like decimals, that are unlike decimals. If I put 11.1 also, because before point the two numbers, the number of quantities, the number, how many numbers are there? Basically there are 2 numbers, right? 2, and in that case also 2, but after point there are 3 numbers and here only 1 number. So in that case we can say that both are unlike decimals, because we are just concerning about what? After point how many numbers are there. So that's the it is a very basic thing that we need to understood. And right now we are ready to deal the questions of exercise 3a. So let's just start exercise 3a. What is the first question? That is, write the expanded form of the following fractions. And what is the first question? That is 0.029. So how will you expand it? So first of all, let's just revise about what do you mean by expanded form. Expanded form is nothing but, if I take 359, so expanded form is nothing but we have to divide that place values. We have to divide that place values, accumulate it with which operator? That is plus. So what do you mean by place value? Here the place value of 3 is nothing but 300, right? Because the 3 is position itself in that which place? 100 place, right? So we can write not like that 300, we will write like 3 into and its position, that is 100, right? So what is the position of 5? That is 10. 5 into 10. And what is the position of 9? That is 9 plus 9. So that is the expanded form of 359. So like that way, if I'm talking about the point part, how will you do it? So we just simply find out 0.0. So 0.029, right? That is the question. So if I am talking about point, after point, what is the position? That is 0. So what do you mean by 0 over here? How will you write it? That is basically 0 into 1 by 10. 0 into 1 by 10, because 0 holds its position in the 10th place. So what is the denoting factor of 10th place? That is 1 by 10. So let's just jump into the position of 2. What is the position of 2? That is hundredths. So how will you write hundredths? That is 2 into 1 by 100. It is very similar to this type also. First of all, we will concern about that position, that is 3. So what is the position of 3? That is 100. So we just write 3 into, we just make that 3 in isolated mode and multiply that with its position. What is the position of 3? That is 100. So in that case, what is the position of 2? That is hundredths. So what is the denotation of hundredths? Basically 1 by 100. Simple. And then plus 9. What is the position of 9? That is thousandths, right? So that is the expanded form of 0.029. Let's just take one more question, that is question number 3. Question number 3, what is the answer here? 53.829. So first of all, let's just concentrate about 5. What is the position of 5? That is what? 10. So how will you write it? 5 into 10, then plus 3, because the position of 3 is in the ones position, so it will remain same, and then the point part. So how will you write it? Plus, we will put plus over here because all the numbers are being accumulated with each other under what operation? That is addition, right? So what is the position of 8? Basically 8 into 1 by 10, because it is coming under in tenths position. Then 2, what is the position of 2? That is 2 into 1 by 100, and then the leftover part is 9, that is 9 into 1 by 1000. So that is the basic expanded form of exercise 3A question number 1. I think it is much more clear to you. So let's just jump into the next question. So here is question number 2. What is question number 2? Arrange the decimals in ascending order. What do you mean by ascending order? What do you mean by ascending order? Smallest to largest, right? So first of all, let's just find out, let's just understand about the methodology of dealing with the points, So if I'm talking about only the numbers, let's say natural numbers, so let's say 56, 67, 82, we can easily find out which is the smallest number over here. Which is the smallest number? Basically it is 56, right? 56 is the smallest number, and in 82 is the largest number. So in that case, how will you find it? How will you find it for points related questions? So let's say 6.7 and then 7.32 and then 6.624, like, so how will you deal with it? So first of all, we will concentrate about before point part, so that is the before point part, right? So we will find out which is the number which is the least number over here. So here the least number is 6, and 7 is the largest number. So we will understand that 7 will come in the later part. So let's just first deal with the 6 portion, right? That is 6.7 and 6.624. So how will you find it? That which one is the largest number and which one is the smallest number? How will you find it? So in that case, before point, when we picked up which one is the largest and which one is the smallest, and after that we will move on to the point part. So here which is the number? That is after point, that is 6 over here, then 2, then 4. So after point, let us compare both of them, that is 6.7 and 6.624. So after point, 6 is over here and then 7 is over here. So which is the largest number? We know that 7 is greater than 6. 7 is greater than 6, though our case is already solved. That is the smallest number over here. So 6.624 is the first number, then comes 6.7 and then 7.32, right? So that is the ascending order. Let us take one more example. So let's take 7.7, let's say 84, and then 6.844, and then let's say 785, right? So in that case, before point, all the numbers are absolutely same, that is 666, right? So after point we have to deal with it. So first of all, let's just find out what is the after point number. In the first number, what is the after point number? That is 7. So in the second number, that is 8, and in the last, there is 7. So in that case, we will easily find out that 6.8, because 8 is greater than 7, we know that. So 6.844 will be the larger number out of these three, right? So we will deal with the first and the last. So here 7, both are same. So we have to keep going on towards right hand side. This is the right hand side and this is the left hand side. Before point is the left hand side and after point will be the right hand side, right? Easy and straight. So after that, what is the number? That is 8, and here also 8. So we will shift on to the next number. So the next number is 4 and here it is 5. So we will easily understand that 4 is smaller than 5. So the first smallest number will be this one, then this one, and then the last one is this one, right? So I think the concept is much more clear to you, and now it is very much easier for us to deal the question number 1 of exercise, question number 2 of exercise 3a. So what is the question? That is 6.92, then 0.87, and then 1.93 and 5.6. So what is the answer? We can easily find out by dealing the numbers on the basis of left hand side and the right hand side. So first of all, we will compare the left hand side over here. Then what is the first number? That is 6. Here there is 0, then 1, then 5. So see, so here there is 0. 0 is the smallest number over here, and we can easily understand that 0.87 will be the first number because the order is ascending. So we have to put the smallest number in the first position. So after that, what is that number? That is 1. What is the number? That is 1. So simply we will write 1.93. So after that, what is the number? That is 5. So 5.6, and last but not the least, that is 6.92. Easy. I think in that case we don't need to go towards right hand side because the left hand sides will be much more distinct for us. So I have created one more complex question which I have discussed before solving this particular question, which is much more easier as compared to this one. So if you understood this question, this example, then you can able to solve any sort of questions related to ascending order, or you can say descending order. So let's just jump into the next question. So now let's just straight jump into question number 4. What is question number 4? Convert each of the following decimals into fractions. We have to convert decimal into fraction in its simplest form. What do you mean by simplest form? The form, after that we will not cancel the numerator as well as the denominator. So let's just straight jump into question number 1, that is 0.02. So how will you first of all how will you convert this decimal number into fraction? How will you do it? The straight and simple answer of that particular question is nothing but, when we are talking about 1 by 10, so that is basically 0.1, right? That is basically 0.1. So how will you do this? How will you do this? So when we want to how will you do this? Basically by showing the division, which I have shown you, right? So if I want to go towards the backward direction, how will you do it? How will you do it? Basically the denominator is 1, so 0.1 by 1, because any number where the denominator is not given, so the denominator will be 1, right? So the denominator will be 1. So how will you deal with this number? So you have to what you have to do, you just simply multiply 10 with each denominator as well as numerator. So what is the net result? 0.1 into 10, 0.1 into 10. So that is basically 10 into 1, that is 10, 1 carry, 10 into 0, 10 into 0, that is 0, plus 1, that is 1. And where is the point? Where is the point? Before what? Sorry, after 1. After 1, that is the point, right? Sorry, before 1, that is the point. Before 1, that is the point. So 1 place. So we have to put point over here, before 1 place. So what is the result? That is 1 by 10. So what do you mean by that? What do you mean by that? The thing is that we have to do what? If I want to convert this numbers, any of such number which is coming under decimal form, we have to do the multiplication part. That is the simplest one. And how will you find it that what is that number? Because in that case I have taken 10. So what is that 0.02? So what is that number, specific number that we have to multiply? How will you find it, right? So it is very much easy. Let's just focus on the board. That is 0.1. In case of point, how many numbers are there? In the right hand side, 1 number is there, so we have to multiply with 10. So after, in that question, in the right hand side, how many numbers are there? That is 2. So what is that number that we have to multiply with? That is 100. Because what? In case of 1, the number of zeros is 1. So in case of 2, the number of 0 will be 2. In case of 3, the number of 0 will be 3. So let's just do this question. So what we have to do? We just have to multiply this number 0.02 that is divided by 1, because if anything is not there in the denominator, so what is there that is intact with that particular number, that is 1. So how will you do it? Basically you have to do 0.02 into 100 by 1 into 100. 1 into 100. So what is the net result? That is 0.02 into 100 will be 2 by 100. So what is 2 by 100? That is 1 by 50. That I will not show. That how this simplest form is going to be happen, because I have discussed properly this concept in my fraction video. So you have to, if you completely watch that particular chapter, then you can able to understand it. So for instance, let's just quickly understand it. So what I have done, that is the common factor between 2 and 100 is nothing but 2. Nothing but 2, because we can write 100 like 50 into 2. So 2 and 2 in both ways, that is in numerator and denominator, will get cancelled out, right? So this is how the result will come. That is one method of doing it, right? The separate method is like we have to expand this number. Expanded form, you know, expanded form is nothing but, here what is the expanded form of this particular number? That is 0 into 1 by 10 plus 2 into 1 by 100, right? 2 into 1 by 100. So 2 into 1 by 100 it will be like this one. So 0 into any number will be 0. So 2 by 100 will be the net result, and simply we will do the same process, that is 1 by 50. So 1 by 50 will be the answer. I think this process is much more easier as compared to this process. So you can follow this process only, right? So let's just jump into question number 3. So how will you do it? By simply doing the expanded form. So what is the expanded form of this particular number? That is 0 into 1 by 10 plus 0 into 1 by 100 plus 3 into 1 by 1000, right? So that is the expanded form, and 0 into any number will be 0. So 0 plus 0 plus 3 by 1000. 3 by 1000. So 0 plus any number will be the remaining number which is intact over here. So 3 by 1000. So any common factor between 3 and 1000 is there? No. So 3 by 1000 is the simplest form of this particular decimal number. So I think instead of doing this particular process, you can follow this process, right? It is much more fruitful for you to do and easier, I guess. So the rest question you will do and just try. If you found any problem, then make sure you do ask me, right? So let's just jump into the next question. So let's just jump into the question number 5. What is question number 5? Convert each of the following as a mixed fraction, right? So what do you mean by mixed fraction? Where one natural number will be there and associated with one proper fraction, right? So that is the example of mixed fraction. So in that case, we have to convert this number into mixed fraction. So how will you do it? Because we know that decimal number is the conversion of, right, is a mixture of natural number and some fraction. How on the basis of what I'm talking about this particular concept? So you just see, if I'm talking about let's say 1.1 is the number, what I just told, that it is a combination of natural number and fraction. So how am I saying this type of things? So natural number is over here before point, that is 1, and then what is the expansion of this one? That is 1 by 10. So you can say that is a mixture of natural number and fraction. So if I associate this number as completely, you will see that 1 by 10 is nothing but 1.1. So how am I doing this? Basically, if you just convert this fraction into improper fraction, you will see that 10 into 1 will be 11. Sorry, 10 into 1 will be 10 plus 1 will be 11, and by 10. So if you divide 11 by 10, you will get 1.1. So I'm just let's just show how this division come into place. So 10 into 1 will be 10. So 1 will be in the remainder part, and then what we have to do, we just have to put the point. So when we put this point, immediately that 0 will come into play, right? So 10 into 1 will be 10, and then remainder will be 0. So in that case, we can say that 1.1 is nothing but 11 by 10, which is the mixed fraction part, that is 1 by 10. So what we have to do, we just need to do the expanded form and simply associate that two numbers togetherly. So in that case, what is the representation of 2.3? 2.3 is nothing but 2 plus 3 by 10, right? 2 plus 3 by 10, that is the expanded form of this particular number, and then we will simply write 3 by 10 as the answer of this particular question. This is the mixed fraction, right? So instead of doing question number 3, I think you have cleared it out that what I'm trying to say. So since I have written this question, let me just solve this one also. Alright, so let me just discuss one more method of solving this particular question. So what is that? Another method of doing this particular question is like, let's understand about one more thing. 1 by 10 is there, so we will write 0.1. So if 1 by 100 will be there, we will write 0.01, right? So if 1 by 1000 will be there, we will write 0.001. So instead of doing this, so if I have let's say 11 by 10. So 11 by 10 means what? The point will come between 1 and 1. Why? Because in the division only 1 0 is there, so we have to put that point before 1, only one place, no? So if 11 by 100 will be there, so how many zeros are there? That is 2. So we have to write point before 2 places of number. So answer will be 0.11. In that case 1.1. So if the same process, if I take 1000 over here, there must be 3 numbers. So there 3 numbers are not existent. So what we have to do, we have to take 0 1 1. We have to take 0 1 1 because 0 1 1 and 11 both are same. So what we have to do, we just need to shift that point before 3 places. So what is the answer? That is 0.011. So I think that decimal point expansion is much more clear to you. So what I'm trying to say is, before point, after point, if 3 numbers are there, let's say 1 to 5, so there is the decimal expansion of 1 to 5 by 1000. So, right? So that is the fractional part of this particular decimal number. So 1 to 5 by 1000 is nothing but 0.125. So instead of instead of doing that, what I'm going to try, what I'm going to say is like, instead of doing that expanded form, we will directly do this. We will directly do this process, right? So if 3 pointer, after point 3 numbers are there, what we have to write? That is 1 to 5 here, 1 to 5 is there after point. So 1 to 5 by 1000, right? So 1 to 5 by 1000. Now the process is not completed. What we have to do, before point, what is that number? That is 3. So 3 plus 1 to 5 by 1000. So that is the basic expansion of this particular number, and simply we will write 3 1 to 5 by 1000. We will write 3 in that middle part, right? So that is the mixed fraction of this particular number, that is 3 1 to 5 by 1000. So let's just revise one more time. What do you mean by this one? This process is nothing but how many numbers are there after point, just replace that number by number of zeros. So how many numbers are there? 3 numbers. So we will write in the denominator how many zeros will be there? 3 zeros will be there. So if the number of point after point, let's say 2 number, it will be there. So what we have to write? 100, right? So that is the easier process of solving this particular question. So I think this question is much more clear to you. So let's just jump into the next question. Alright, so we are coming towards the end of this particular session. So what is the last question of today's video is convert each of the following decimals into like decimals. So what do you mean by like decimals? Like decimals is nothing but after point the number of numbers, like the how many numbers will be there, it must be same. If the numbers, if the number of numbers if the quantity of numbers will be same, then we can say that these are coming under like decimals. So like let's say if I take this example, that is 5.8, 19.07 and 0.296. First of all, one more thing that I just forgot to tell you, that how will you pronounce this number, right? So if I take like 17.17, what I just said, 17.17. So in that case, after point we have to individually individually name that particular number. So before point we will clubbed that number, let's say 1 lakh, 2 lakh, 2,43,243.123, right? So 0.123 we will individually call each of the numbers. So in that case, what is that number? That is 17 point, before point what is that number? That is 17, and after point what is the number? Again 17, but we will not say 17.17, no, we will say 17.17. So that is the that is how you can actually pronounce that particular number. All right, so let's just jump into that question. That is 5.8, 19.07 and 0.296. So first of all, let's just understand about what is that like decimals. The like decimals is nothing but after point the number, the quantity of number, it should be same. So in that case, what is the highest number? That is 296. 296 contains 3 numbers, right? 3 numbers, and the rest numbers have like 2 numbers will be there here, 1 and then 1. So we have to fill all such numbers into what? 3 number quantity. So how will you do it? Basically we will do 5.800. so if you put thousands of zeros over here, the net result will be 5.8. it will not change, right? So before point like before 5, if you put thousands of zeros, it will same, and after that number if you put thousands of zeros, it will also same, or crores of zeros. The net result will be 5.8. The net result will be 5.8. But one thing that you have to remember, that is 6 and 5, if these numbers will be there, and if you put thousands of zeros in between 6 and 5, so that will change its meaning. So in case of point also, 7008 will be there, we cannot do that, right? So in case when the numbers will be coming towards its end, in the end point you can add many of the zeros as far as the question is concerned, right? So in that case I need 2 more zeros because to satisfy that 3 number quantity. So in that case, what is the next number? That is 19.07. so how many zeros will be required? Only 1, right? And then 0.296 will remain intact, and what is the last number? That is 118.1, and how many zeros will be required to fill up? That is 2 zeros. So that's all for today's video, and whatever the question that is left over before 7, or let's say in that 7 question also, you have to do in your classwork copy, and rest of the things whatever I have discussed, you have to write it down, right? Make it a note freshly, because soon I'm going to give you the Google Classroom link where you have to submit all your like notes, or you have to submit your copy basically, right? So make sure you have to be up to date. And that's all for today's video, and later on I will make one more video of exercise 3A and solve some questions. All right, thank you and bye bye.